January 12, 1945. Boeing Plant 2, Seattle. Senior engineer Eric Johnson stood before the completed B-29 Superfortress, aircraft number 7143. The massive bomber gleamed under the factory lights, pressurized cabin, remote-controlled gun turrets, bomb bay capable of carrying 20,000 pounds. Everything about this aircraft exceeded anything the Luftwaffe could field. Yet what haunted Johnson wasn't the technological marvel before him. It was the telegram he'd received that morning from the War Department. German intelligence had designated this single factory as Target Priority Alpha. Their assessment concluded that Boeing Seattle alone was producing more strategic bombers than their entire remaining aviation industry. They weren't wrong. What the Germans didn't know was that Johnson and his team were about to double production again. The story began 3 years earlier with an impossible demand. December 1941, days after Pearl Harbor. General Henry Arnold stood before Boeing's senior engineering staff with specifications that defied physics. He wanted a bomber that could fly 5,400 miles, carry 10 tons of bombs, operate at 32,000 feet, and possess defensive armament exceeding most fighters. Oh, and we need 500 of them by next year, Arnold added. The B-29 program would consume more resources than the Manhattan Project, yet few Americans would ever know its name. Eric Johnson had joined Boeing in 1938 as a junior structural engineer. The son of Swedish immigrants, he'd grown up in Minnesota watching his father's small manufacturing business collapse during the Depression. That experience taught him that survival demanded efficiency, innovation, and relentless problem-solving. By 1942, he'd become the lead engineer for production optimization, charged with transforming the B-29 from experimental prototype to mass-produced weapon. The challenge was staggering. The B-29 contained 55,000 parts compared to the B-17's 32,000. Its pressurized cabin required sealing tolerances previously achieved only in submarines. Its Wright R-3350 engines generated so much heat they routinely caught fire during testing. Its remote-controlled gun turrets employed computation systems that didn't exist in commercial aviation. Every aspect pushed engineering boundaries. But Johnson's real challenge wasn't technical. It was temporal. Germany was developing jet aircraft. Japan controlled the Pacific. Every month of delay meant thousands more Allied casualties. The mathematics were brutal and inescapable. "We're not building experimental aircraft," Johnson told his team in January 1943. "We're building a production system capable of manufacturing complexity at scale. There's no blueprint for this. We're inventing it as we go." The Nazi leadership, meanwhile, dismissed American bomber development with familiar contempt. In March 1943, Reichsmarschall Hermann Göring received intelligence reports describing Boeing's B-29 program. His response, documented in captured Luftwaffe records, dripped with derision. The Americans believe they can pressurize a bomber and operate at 30,000 feet while maintaining defensive firepower. They understand neither aerodynamics nor combat reality. Their aviation industry excels at producing training aircraft and transport planes. Strategic bombers require engineering sophistication they simply don't possess. Göring's technical advisors, however, weren't so certain. They noted that Boeing had solved seemingly impossible engineering challenges before. The four-engine B-17, laughed at by German designers in 1935, had become the backbone of Allied bombing campaigns. What if the Americans achieved similar breakthroughs with the B-29? Göring dismissed such concerns as defeatist anxiety. By the time he recognized his error, Seattle's production lines were operating 24 hours daily. Johnson's first breakthrough came not from engineering but from organizational psychology. Traditional aircraft manufacturing followed craft production principles. Master craftsmen assembled planes sequentially, each aircraft slightly different. Johnson proposed the opposite. Break the B-29 into 5 major sub-assemblies: forward fuselage, center wing section, aft fuselage, outer wing panels, and tail assembly. Manufacture these components in parallel at different facilities, then integrate them on a moving assembly line. It was automotive thinking applied to aircraft engineering. The resistance was immediate and fierce. Senior Boeing engineers argued that aircraft were too complex for assembly line production. Each B-29 would require custom fitting and adjustment. Standardization was impossible. Johnson countered with data from automotive manufacturing. Ford produced one vehicle every 90 seconds with zero custom fitting. The solution wasn't simplifying the aircraft. It was standardizing the tolerances. By June 1943, Johnson's system was operational. Boeing's Seattle facility became the integration center, receiving subassemblies from Renton, Washington and Wichita, Kansas. The breakthrough came in the tolerance specifications. Johnson demanded that every component meet standards precise to within 0.005 inches. This required revolutionary quality control, statistical sampling, coordinate measurement systems, and continuous inspection protocols that didn't exist in aircraft manufacturing. The costs were enormous. Rejected components averaged 22% in the first 6 months. But those that passed could be integrated without modification. By December 1943, Boeing Seattle was producing 16 B-29s daily. No factory in history had manufactured something so complex at such volume. German intelligence finally grasped the implications in early 1944. A captured Luftwaffe analysis, now in the National Archives, calculated that Boeing's Seattle plant alone possessed greater strategic bomber capacity than all Reich aviation production combined. The assessment concluded with unusual frankness: this represents industrial capability we cannot match. Their system superiority exceeds our technical advantages. The implications for air superiority over the Reich are catastrophic. But Johnson and his team faced challenges beyond production volume. The B-29's complexity created a nightmare of parts logistics. Each aircraft required components from 8,000 suppliers across 30 states. A shortage of a single specialized valve could halt entire assembly lines. Johnson's solution revolutionized supply chain management. He implemented a punch card system, forerunner of modern computing, that tracked every component's location, quantity, and expected delivery. The system processed 150,000 inventory updates daily, coordinating delivery of millions of parts within 48-hour windows. The breakthrough's magnitude only became apparent in comparison. German aircraft production, increasingly dispersed into underground facilities, descended into chaos. Parts manufactured in Bavaria didn't fit airframes assembled in Saxony. Quality control collapsed. By mid-1944, approximately 40% of German aircraft left factories with defects requiring extensive repair. American aircraft, produced in facilities Germany couldn't bomb, maintained defect rates below 2%. The human dimension of this transformation proved equally revolutionary. Boeing Seattle employed 28,000 workers at peak production. Nearly 40% were women. Unlike the stereotypical Rosie the Riveter narrative, many performed highly technical work. Dorothy Harper, hired as a quality control inspector in 1943, developed the statistical sampling protocols that reduced wing assembly defects from 8% to 0.4%. Her innovations, born from practical problem-solving rather than theoretical training, were subsequently adopted across American aircraft production. Johnson recognized that democratic production, workers contributing ideas regardless of hierarchy, generated innovation impossible in command-driven systems. He implemented a suggestion program that received over 2,000 worker recommendations monthly. Approximately 30% were adopted. One suggestion, from a night shift machinist named Robert Chen, redesigned the engine cowling installation process, reducing assembly time from 8 hours to 3. That single change, multiplied across 16 daily aircraft, added 5 monthly B-29s to production. By June 1944, the B-29 began combat operations from China against Japanese targets. The results vindicated every engineering decision. Operating at altitudes beyond Japanese fighter interception, B-29 struck with impunity. Their pressurized cabins allowed crews to operate without cumbersome oxygen equipment. Their remote gun turrets, coordinated by the Central Fire Control System Johnson's team had perfected, destroyed Japanese fighters at ranges exceeding 1,000 yards. The strategic implications cascaded rapidly. In November 1944, B-29s began operations from the Mariana Islands, bringing Japan's home islands within range. A single raid on Tokyo, March 9, 1945, dropped more tonnage than all American bombing of Japan in 1942 to 1943 combined. This wasn't tactical bombing. It was industrial demolition delivered by an aircraft system Germany had dismissed as impossible. Hermann Göring's recognition of Boeing's achievement came through intelligence summaries that reached him sporadically in 1944. By then, cut off from operational control, he could only witness the Luftwaffe's destruction from afar. Documents from his interrogation reveal his obsession with Boeing's production numbers. He repeatedly asked interrogators to confirm whether Seattle really produced 16 B-29s daily. When assured it was accurate, he responded with stunned silence. The mathematics had become inescapable. By war's end, Boeing Seattle alone had produced 1,119 B-29s, more four-engine strategic bombers than Germany manufactured throughout the entire conflict. The cost per aircraft, initially $900,000, dropped to $640,000 through production efficiencies. This made the B-29, the most complex aircraft ever mass-produced, more cost-effective per pound of bombs delivered than simpler aircraft Germany struggled to manufacture. Johnson's system innovations extended beyond wartime production. The statistical quality control methods pioneered at Boeing became standard industrial practice worldwide. The parts tracking systems evolved into modern supply chain management. The subassembly approach to complex manufacturing influenced everything from automobiles to spacecraft. The engineers who solved B-29 production challenges later designed the 707, the first successful commercial jet, launching the modern aviation age. The human cost of this achievement deserves equal emphasis. Johnson worked 80-hour weeks from 1942 through 1945. His marriage collapsed under the strain. His health deteriorated from stress and exhaustion. Yet he considered the sacrifice absolutely necessary. "Every B-29 we don't produce costs Allied lives," he wrote to his brother in March 1944. "The pressure is crushing, but the alternative is unthinkable." On August 6, 1945, B-29 number 44 to 86,292, named Enola Gay, departed Tinian Island carrying a single atomic bomb. The aircraft performed flawlessly, pressurization system maintaining cabin environment, engines operating without overheating, all systems functioning precisely as designed. The bombing of Hiroshima, followed by Nagasaki 3 days later, ended the war and saved millions of lives Allied invasion would have cost. Johnson was working the night shift at Boeing Seattle when news arrived of Japan's surrender. His first response wasn't celebration but verification. He walked the assembly line, checking that every aircraft under construction met specifications. 17 B-29s were in various stages of assembly. All would be completed, he insisted, despite war's end. "We finish what we start." Hermann Göring's final assessment of American production came in his October 1946 letter before suicide. Among the bitter admissions of defeat, he wrote with unusual specificity about Boeing, "A single American factory produced strategic bombers exceeding our entire nation's output while maintaining quality we couldn't match in prototypes. This wasn't superior resources. It was superior systems. Their engineers understood production as warfare. We understood warfare but not production." The strategic lesson proved enduring. In total war, production capacity determines outcomes more surely than tactical brilliance. The side that can manufacture complexity at scale, maintain quality under pressure, and innovate continuously possesses decisive advantage. Johnson's team at Boeing demonstrated that free workers, empowered to contribute ideas and held to rigorous standards, could achieve manufacturing excellence totalitarian systems couldn't approach. The B-29's legacy extended far beyond military victory. The pressurization systems pioneered for high-altitude bombing enabled commercial aviation's growth. The engine cooling solutions that prevented AR-3350 fires influenced jet engine design. The remote-controlled turret computers represented early steps toward aviation electronics. Every technical challenge Boeing overcame for wartime production generated innovations that shaped the aviation industry for decades. Johnson remained at Boeing after the war, eventually becoming vice president of manufacturing. He rarely discussed his wartime role, deflecting credit to the thousands of workers who'd built the aircraft. When pressed by historians in the 1960s, he offered a characteristic response: "We didn't think of ourselves as heroes. We were engineers and workers doing a job that needed doing." The satisfaction wasn't individual achievement but collective success. Yet the numbers tell a story Johnson's modesty obscured. Boeing Seattle's production system, refined under crushing time pressure and impossible demands, revolutionized manufacturing itself. The principles Johnson pioneered, modular design, statistical quality control, coordinated supply chains, worker empowerment, became foundational to modern industrial production. The B-29 program proved that American engineering, supported by democratic collaboration and disciplined execution, could achieve the impossible. Today, Boeing's Seattle facilities continue aircraft production, a direct lineage from Johnson's wartime innovations. The engineers working there benefit from systems he created 8 decades ago. The statistical methods, the supply chain coordination, the quality control protocols, all trace roots to desperate improvisations that became permanent innovations. History remembers the B-29 for ending World War II. Engineering history remembers it for revolutionizing how complex systems are manufactured. Hermann Göring laughed at American bomber production, dismissed strategic aviation as beyond American capability, and died knowing his contempt had been catastrophically wrong. Eric Johnson, working 80-hour weeks in a Seattle factory, responded not with rhetoric but with results. 16 B-29s daily, each one exceeding German technical achievements, every one produced by workers Göring dismissed as incapable of sophistication. The final tally couldn't be clearer. Boeing Seattle, 1,119 strategic bombers. All German 4-engine bombers combined, approximately 800 throughout the entire war. This single American factory exceeded an entire nation's output while simultaneously advancing aviation technology by a decade. The engineers and workers who achieved this transformation didn't just build aircraft. They proved democracy's productive superiority over tyranny, civilian innovation over military command, collaborative problem-solving over hierarchical dictates. Johnson understood this broader significance. In a 1963 interview, he reflected, "The B-29 program taught me that free people, united in common purpose, can accomplish what seems impossible. We weren't smarter than German engineers. But our system, democratic, flexible, innovative, proved superior to theirs." That's the real lesson. Not American exceptionalism, but democratic exceptionalism. The lesson resonates today. Dismissing democratic nations' industrial capacity because they prefer commerce to conquest invites catastrophic miscalculation. Underestimating free people's ability to mobilize and innovate when facing existential threat repeats Göring's fatal error. America in 1941 appeared unprepared for strategic bombing. By 1945, a single factory had transformed global warfare forever. Eric Johnson died in 1979, his contributions largely forgotten outside engineering circles. No monuments bear his name. No holidays commemorate his achievement. Yet every modern aircraft, every complex manufactured system, every supply chain coordinating thousands of components, all rest on foundations he helped build. The B-29 wasn't just a bomber. It was proof that engineering excellence, democratic collaboration, and systematic innovation could change history. Hermann Göring's contemptuous dismissal of American bomber production echoes through history as catastrophic misjudgment. Eric Johnson's quiet response, 16 B-29s rolling off assembly lines daily, echoes as triumphant vindication. Between contempt and competence lies the difference between defeat and victory, between tyranny's collapse and democracy's triumph. The Reichsmarshal laughed at American engineering. America responded by building the aircraft that ended the war and transformed manufacturing forever. His laughter became history's sound of total defeat.